Ever wondered what makes the difference between physisorption and chemisorption? Well, strap in, because today we're unraveling the mystery of adsorption, an essential concept in chemistry that has a wide range of applications, from water treatment to gas storage. First, let's start with the basics. Adsorption, not to be confused with absorption, is the process of molecules, ions, or atoms, collectively known as adsorbates, sticking or attaching themselves onto the surface of another substance, known as the adsorbent. Now, while this might seem simple, things get a little more complex when we delve into the two main types of adsorption, physisorption and chemisorption. Physisorption, also known as physical adsorption, is the milder of the two. It involves weak van der Waals forces between the adsorbate and the adsorbent. These forces are so gentle, in fact, that the heat of adsorption is quite low, typically between 20 and 40 kilojoules per mole. This type of adsorption can form multi-layers of adsorbed particles, and it's not picky. It isn't specific in nature. Some examples of physisorption include pore filling and pore diffusion, both of which are influenced by van der Waals forces. On the other hand, chemisorption or chemical adsorption is a bit more intense. It involves strong chemical bonds, specifically covalent bonds between the adsorbate and the adsorbent. These bonds are so strong that the heat of adsorption is significantly higher, ranging from 40 to 200 kilojoules per mole. Chemisorption forms a single monolayer of adsorbed particles and is very specific in nature. Some examples include hydrogen bonding, surface complexation, and pi-pi interaction. So, in a nutshell, the fundamental difference between physisorption and chemisorption lies in the nature of the forces involved: weak van der Waals forces for physisorption and strong chemical bonds for chemisorption. Now that we've defined these two types of adsorption, let's delve deeper into their unique characteristics. Physisorption and chemisorption, though similar, perform their magic in unique ways. Let's dive deep into the world of these two fascinating processes. Physisorption, also known as physical adsorption, is a process driven by weak van der Waals forces between the adsorbate and the adsorbent. It's akin to a casual handshake, not too firm, not too loose. These interactions result in a low heat of adsorption, typically around 20 to 40 kilojoules per mole. One of the distinctive features of physisorption is that it forms multi-layers of adsorbed particles. Imagine a stack of pancakes, one on top of the other. It's also non-specific in nature, which means it doesn't play favorites. It can occur with a wide range of molecules, with examples including van der Waals forces, pore filling, and pore diffusion. Chemisorption or chemical adsorption, on the other hand, is more like a firm, assertive handshake. It involves the formation of strong chemical bonds, specifically covalent bonds between the adsorbate and the adsorbent. This results in a high heat of adsorption, typically in the range of 40 to 200 kilojoules per mole. Unlike its physical counterpart, chemisorption forms a monolayer of adsorbed particles. Picture a single, orderly layer of pancakes on a plate. This process is specific in nature, meaning it's picky about the molecules it interacts with. Examples of chemisorption include hydrogen bonding, electrostatic interaction, surface complexation, surface precipitation, and pi-pi interaction. So while the two may seem similar at first glance, physisorption and chemisorption are quite distinct in their properties and applications. Remember, the devil is in the details. Let's continue to explore the wonderful world of adsorption, where every detail counts and every interaction matters. So stay tuned, stay curious, and let's unravel the mysteries of the micro world together.